Welcome to Jom Studylah YouTube channel. As we continue our presentation on hydrocarbon, we will now focus on the next key area, the IUPAC naming conventions for alkane, hydrocarbon, which provide a standardized framework essential for clear communication and documentation in the chemical industry. Without further ado, let's get started. Alkane for step 4. Branch change alkane are named according to the following IUPAC rules. IUPAC rules stand for International Union of Pure and Applied Chemistry. When naming hydrocarbon like alkane that has two or more substituent group attached to the main, like methyl and ethyl, first you need to identify the longest continuous carbon change, where you need to find the longest straight change of carbon atom, and in this structure, the longest change has 6 carbon atoms, which make it a derivative of hexane. So, for carbon 1 is CH3, and for carbon 2 is CH with CH3 as a branch, and for carbon 3 is CH2. For carbon 4 is a CH with an ethyl group, which is CH2 and CH3, the branch, and for carbon 5 is CH2, and for carbon 6 is CH3. So the parents for this example, parent change is hexane 6 carbon atoms. Second, then you have to number the carbon change. So in order to number the change in such a way that the substituent branches get the lowest possible number. Let's look into the option 1, where you have to number from left to the right. So in this case, you can see that CH3, which is at the position of carbon 2, is referred to CH with CH3 as a branch, where it is actually meant for methyl group. And at the carbon 4, we have a branch CH with an ethyl group, which is CH2 and CH4. And this is referred to the ethyl group on C4. And for the options 2, we have, you need to number from right to the left, where in this case, carbon 6 is referred to CH3, and carbon 5 is referred to CH2, where CH2 with a branch as CH2 and CH3. And at the position of carbon 3, where its branch with a CH3. So in this case, ethyl is on carbon 3 and methyl is on carbon 5. So in option 1, numbers are referring to 2 is methyl and 4 is ethyl. So in option 2, where numbers are 3 ethyl and 5 methyl. So the options that give the lowest number at the first point of difference, option 1 is correct, because 2 is less than 3. Then you need to alphabetize the substituent. When writing the IUPAC name, alphabetical order matters for substituent. And thirdly, for the prefixes like DI, TRI, SEC, TLRT are ignored for alphabetizing, but for ISO and NEO are not ignored. So in this case, ethyl comes before methyl, so in the alphabet. So when you write the final IUPAC name, putting it all together, you get the name of 4-ethyl 2-methylhexane. Hexane is the parent change where consists of 6 carbon atom and substituent ethyl at carbon 4 and methyl at carbon 2, and listed alphabetically ethyl before methyl. And then 4-ethyl 2-methylhexane follow IUPAC rules. And then refer to the step number 5. The condition for the step number 5 is when 2 or more branches substituent groups are attached to the same carbon atom in the main change, you have to use that carbon number for each branch individually in name, example, as shown below. The name is 3-ethyl and 3-methylhexane. The first step is you find the longest continuous carbon. Where carbon change, find the longest continuous change of carbon atom, where in this case, the longest change here has 6 carbon atom, which makes the parent names is hexane. Then you have to number the change. We number the chain from the end closer to the substituent to give the lowest possible number to the branches. So on carbon 3, there are 2 substituents, which is a methyl group, CH3, and ethyl group is CH2 and CH3. And then you need to identify the name, the substituent, which is ethyl is branched out to the chain CH2 and CH3, and methyl is CH3. So both are attached to carbon 3. So we write 3-ethyl and 3-methyl. Then you have to combine the names alphabetically, ethyl name before methyl. So 3-ethyl and 3-methylhexane. Then we look at the alkane step 6. What are the conditions for the step 6? When naming organic compound with 2 or more identical side chain substituent, we have to use special prefixes to show how many are present. For example, Di means 2 identical group, Tri means 3 identical group, Tetra means 4 identical group, and you have to use comma to separate numbers that indicate position, like 2 or 3, and hyphen to separate numbers from words like 2,3-dimethylbutane. Then you need to find the longest continuous carbon change. So the longest straight change here has 4 carbon atom. So the base name is butane. From BUT is equal to 4. And carbon atoms A and E is referred to all single bonds. And then you need to identify and name the substituent where you have 2 methyl group CH3 attached to the main change. And there are identical substituents, both are methyl group. Number the carbon change. When you number the main change from the end, that gives the substituent the lowest possible number. So in this case, numbering from left to the right. So you can see for carbon 1 is CH3, carbon 2 is CH, and carbon 3 is CH, and carbon 4 is CH3. Where at carbon 2 is branched out to CH3, and at carbon 3, it's branched out to CH3. So methyl groups are on carbon 2 and carbon 3. Then you have to put all together 2 identical substituents, which is equals to use prefix Di. The positions are 2 and 3. You name it as 2,3-dimethylbutane. Then you have to naming breakdown, where 2,3 is a methyl group on carbon 2 and 3, and di or D is referred to 2-methyl group, and methyl is name of substituent, and butane is referred to the main change where a 4 carbon and single bond. And for the final IUPAC name is 2,3-dimethylbutane. Then we go through to step 7. What are conditions for the step 7? is when two changes of equal length are possible, choose the change with the greater number of substituents. So this will ensure that the name reflects the most substituted or branch structure, which better represent the molecule complexity. This is the example. Then we have the option 1, which is show the correct IUPAC name, and option 2, which is showing the incorrect name. And we have the reason why the option 1 is correct and why the options 2 is incorrect. So for the option 1, which correct IUPAC name, parents change is heptane, which is consists of seven carbon straight change, and the substituent is methyl group at the position 2, 3, and 5. 2, 3, and 5. A propyl group is at position 4, carbon 4. And the name 235 trimethyl 4 propane heptane is total substituents that we have is 4. Refer to the example in the diagram 2. And then for option 2, why the name is incorrect? Because the parent change, as we know, is also 7 carbon change, but chosen in a way that captured a sec-butyl group instead substituent. Sec-butyl group at the position of 4 and 2-methyl group at position 2 and 3. And name 4 sec-butyl 2 and 3 dimethyl heptane, and the total substituents is 3. So why option 1 is incorrect? Because even though both options have a 7 carbon parent change, the IUPAC rule states that choose the change with the greater number of substituents. So in this case, option 1 has 4 substituents and 3-methyl plus 1 propyl, which is correct. And for the option 2, why is incorrect? Because option 2 has 3 substituents, 2-methyl plus 1 SEC-butyl, which is less preferred. And even though SEC-butyl is a larger group than methyl, we count the number of substituent groups, not their size or complexity. And for this steps 8, what are the options? What are the conditions? Start numbering from the end that give the lowest number to the first substituent. And if both directions give the same number at the first substituent, then move to the second one. And choose the direction that give the lowest number at the first point where there is a difference. And look at this example. So this example has been numbered from N, which is from the left to the right and from right to the left. And the name for this example is 2,3,4 trimethylhexane, not 2,4,5 trimethylhexane. This is a hexane change which is consists of 6 carbon atom in a straight change with 3 methyl, which is branch at CH3 group as branches. Now we need to number the main change to give the substituent the lowest possible sets of number. Then we number it from left to the right, where CH3 in this case is referred to carbon 1, carbon 2 is CH, and carbon 3 is CH2, carbon 4 is CH, carbon 5 is CH, and carbon 6 is CH3. Where carbon 2 is branches to CH3, and carbon 4 it branches to CH3, and carbon 5 is branches to CH3, which is substituent methyls are on carbon 2, carbon 3, and carbon 5. That gives 2,3,5 trimethylhexane. When we number it from right to the left, where carbon 6 at the position of CH3, carbon 5 is CH, which is branched out to CH3, Carbon 4 is CH2. Carbon 3 is CH branches out to CH3. And carbon 2 is CH branches out to H3. And carbon 1 is CH3. And substituents would be on carbon 2, 4, and 5, which is give 2, 4, and 5 trimethylhexane. And first substituent in both options, carbon 2 is the same. Second substituent from left to the right is carbon 3, and from right to the left is carbon 4. So at this point, there is a difference, and the lower numbers, 3, comes from the left to the right numbering. Therefore, the correct IUPAC name is 2,3,5-trimethylhexane. The reason 2,3,5-trimethylhexane is correct is because you compare the full set of locane 235 versus 245. And the first difference is at the second number, 3 versus 4. Since 3 is less than 4, 235 is preferred. And this ensures the substituents get the lowest possible number, which following IUPAC, first point of different rules. Oh, that's all for today's sessions. And I look forward to seeing you at the next session. And the next session, we will discuss about the hydrocarbon, the type of hydrocarbon, and the cycloalkane is actually a cycloalkane is a branch out from alkanes itself. So cycloalkane is a saturated alkane which carbon atoms are joining rings. So please subscribe to Jom Studylah YouTube channel. Don't forget to turn on your notification so you don't miss any update. Best of luck in your studies, and thank you very much for your support and cooperations.